Hello, we're going to talk about Chapter 1. This lecture is divided in 3 segments, so this is the first segment. In this Chapter 1, we're going to talk about the introduction to statistics, variables, and data. The learning objectives is that by the end of this module, you should be able to explain what statistics is, explain what descriptive statistics and inferential statistics are, identify a population and explain why sampling is necessary, explain how a representative sample is obtained, identify an element, an observation, and a variable in a data set, and finally, you should be able to identify the type of a variable. So we'll talk about these topics. I should make it clear that I do not cover every topic in Module 1, only these topics. And the homework will target only these objectives. All right, statistics. I'm sure you have heard the word statistics, and this is generally used as a numerical fact. For example, the percentage of Hispanics in the U.S. is 16.7%. That's what people will say, oh, that's a statistic. All right, from our point of view, statistics is defined as the science of collecting, organizing, analyzing, and interpreting data to make better decisions. So here we're taking a more ample definition of what statistics is. Furthermore, we divide statistics into 2 general branches. The first one, we call it descriptive statistics, and that's where we describe data using tables, summary statistics, and graphs. Summary statistics like the mean or the median or the standard deviation. So chapters 2 and chapter 3 will, that's where we will talk about descriptive statistics. The other branch is called inferential statistics, and this is where we use sample results to make inferences, that is, decisions or predictions about a population. So starting off with chapter 4, we're going to start building the knowledge that we require to be able to do inferential statistics. So as you can see, the major part of this course will be focusing on inferential statistics that uses descriptive statistics as part of attempting to make an inference. All right, so that's statistics and its 2 main components. And here's an example of these 2 parts of statistics. So let's, in this example, I'm looking at the rate of infection with COVID-19, or the number of people that are tested as having COVID-19 in San Antonio. So I went to the website for the San Antonio city, and I looked on August 6th, the results by 7 p.m. So the descriptive statistics in this case are summarized as the number of cases, 41,939. This is the cumulative number of cases, and this is the number of new cases in this particular day. The number of deaths accumulated up to date is 406, and there were 12 new deaths on this particular day. So these are the summary statistics that the city is using to report cases and deaths. Also, the city produces this graph where they're showing the cumulative number of deaths from the very first death that was recorded up to today. You can see it seems to be growing quite rapidly, at least up to this date, I'm sorry. So these are the descriptive statistics, so numbers, tables, and graphs. This is another graph. I found it at this website, and this is the number of deaths in the state of Texas. And as you can see, the number of reported deaths up to today is here. So this is what has been observed. However, they are using models to project what would the number of deaths be if all the restrictions are eased. This is the current projection, and this is the projection if we continue to use face masks or face covering. And because these are made in the future, So we are inferring that this is what is going to happen in the future under these different conditions. So this is an example of inferential statistics. So we're using a sample to make projections for the population in the future. In other words, what we have observed currently to what will happen in the future. So that's an example. Now let's consider another example, because now we want to talk about the idea of population and a sample. Now, a current dilemma for the city official is to whether or not to open businesses and schools. And that decision is based on the current rate of infection with the virus that causes COVID-19. The current rate of infection is defined as the proportion of individuals living in Bexar County, or all individuals living in the county that test positive for the presence of the virus that causes COVID-19. Now, I mean, I think it's clear to you that testing every resident of the county, well, is not possible because not everyone is available for one thing, and there are not enough tests to test everyone. So, because of these restrictions, then what the county is doing then is testing only a proportion of those residents to estimate the actual rate of infection among all county residents. So this example is bringing us to the two definitions of the population and that of the sample. So a population is defined as consisting of all elements, either people, animals, or items, whatever you're studying, whose characteristic of interest is being studied. Like in here, we're looking at people that have the virus that causes COVID-19. A sample is just a subset of the elements of the population that we selected for the purpose of studying a characteristic of interest, in this case, having the virus that causes COVID-19. So if we go back to our example, testing every resident in the county, well, that we're talking about the population of people residing in the county. Because we cannot test everyone, then we're going to use a sample of individuals or sample of residents in the county, and we're going to test them for the presence of this SARS-CoV-2 virus. So this is the definition of population, and this is the definition of a sample, and here's an example of this. All right, let's continue with this, because now we need to see what kind of a sample we need to correctly estimate the proportion of people infected with this virus. All right, but before we go there, you will find often the question as to, well, why do we need to sample? Well, typically the population is very large, therefore takes time and money to test everyone in the population. So often the budget, the money, restricts us from testing everyone or studying every member of the population, or we simply do not have the time. And sometimes it's just plainly impossible to evaluate every person in the population. Why? Because we cannot locate them, or our tests destroy the element. Like in industry, we have these destructive tests where, for example, we want to test the strength of the brick. We use a press to press the brick and see how much force we need to break that brick, and that force at which the brick, at the point at which the brick breaks, we call that the pressure to break the brick. But imagine if we want to test every element in the population, we'll end up with no bricks because we will destroy all. Or many times, members of the population are not known or are not accessible. You may think of the illegal immigrants in the U.S. that we want to count with the census. Well, we really don't know where they are. And even if we know who they are, they may not be accessible because they don't want to participate. So sampling tends to be a very good solution to not being able to evaluate every member in the population. All right, I'm going to stop here, and then I will continue with the slides in the next segment. Thank you.